of Oklahoma Robotics Design Summary Video. My name is John Bohr, and I would like to introduce you to my teammates Chad Meadows, Patrick Dolan, Saeed Ali Medinakvi, and Aditya Sharma. We are the University of Oklahoma's 2017-2018 Robotics Design Team. Our team takes safety very seriously. Throughout the entire design and engineering process, we follow the hierarchy of hazard control. We consistently work to eliminate, substitute, engineer, and control hazards that may be found in the drilling environment. The last line of defense, equally important as the rest, is personal protective equipment. Working with the mindset set on safety ensures that the team is in a secure and comfortable work environment, which allows us to perform at our best.
The rig features a cantilever design that allows the derrick to lay down horizontally for easy maneuverability. When inclined to the drilling position, the rig has a height of 110 inches. The traveling block is attached to the derrick through pillow block bearings and a linear guide rail which work together to reduce friction. A 250 psi air cylinder is used in a pneumatic system to raise and lower the traveling block, as well as to apply weight on bit which exceeds the gravitational load of the block. The motor, water swivel, torque sensor, RPM sensor, and load cells are housed on the traveling block. The top drive is powered by a 3-phase 1-horsepower AC motor which provides up to 4.5 pound-feet of torque and 1200 RPMs to the drill pipe.
Our drilling rig uses 8 sensors to monitor the drilling process. The first one is the distance sensor. It's based on a laser module and is used to measure the distance traveled by the traveling block during the drilling process. Next is the RPM sensor that is used to measure the RPM of the drilling pipe. A torque sensor to measure the torque produced by the motor on the drill pipe. An axial vibration sensor used to measure the vibrations experienced by the traveling block. A load cell that measures the weight on bit. A pressure sensor to measure the pneumatic pressure of the cylinder that controls the motion of the traveling block. A pressure sensor and flow meter to monitor the mud circulation system, and finally a downhole sensor, downhole torque sensor that is designed using strain gauges, and it measures the torque experienced by the drill bit.
The design improvements for this year's rig fall in 3 major categories: safety and reliability, control of drilling dysfunctions, and implementation of remote control and plug-and-play capabilities. Improvements to safety and reliability will include electrical upgrades, such as the separation of low and high voltage wiring and the installation of GFCIs. Containment of drilling fluids and cuttings will be achieved through the use of a tray, which will collect these materials and divert them towards a drain. Polycarbonate safety shielding will be installed around the rig to prevent flying debris from injuring personnel. Hazard warning signs will be used to alert personnel of danger. Control of drilling dysfunctions will include improvements to the control algorithm, which will be expanded to better detect formation type and optimize the weight on bit and rotary speed based on these determinations. Better detection of mechanical failure, such as connection failure, will be built into the control algorithm. Also, the connection will be redesigned and tested using several different methods and take into account the thicker drill pipe to prevent these connection failures in the first place. Remote connection and plug-and-play capability will be a feature of this year's rig. This will allow for remote control and monitoring by anyone who has a personal computer, an internet connection, and the password for the rig. 3 cameras will be installed to monitor the drilling operation at the drilling site. At least one of these cameras will have pan, tilt, and zoom capabilities. A complete redesign of the control monitoring interface to match industry standards will be implemented. Here you can see last year's control interface. This year's control interface will be similar to this industry model, which will allow for easier interpretation by people monitoring the drilling operation. On behalf of the University of Oklahoma 2018 Drill Robotics team, I'd like to thank you for looking into our design. Complete details can be found in our final design report.